Okay, so just to remind ourselves, the Newton-Raphson formula is in formula booklet, page 8. Okay, and it's calculated based on the gradient value here, you'll notice. Yeah, that's kind of important. So it's all to do with the tangent. Now, just to sort of roughly give you an idea how it works. Just remember, of course, with Newton-Raphson, suppose you've got a curve there and it equals to cos x, for instance, and you want to find a root, okay? So you could use Newton-Raphson. So if you want to find a root, what you need to do, of course, is to get everything on to one side, okay? So you would set it to equal 0. So maybe we could do that, okay? We could take the cos x over, and then you've got 1 minus x cubed minus cos x equals to 0. We would then call this my function f of x, okay? And we've got f of x equals 1 minus x cubed minus cos x. Of course, I'm interested in where f of x is equal to 0, yeah? That's where I want to find my root. So I got a solution for this where these two curves are actually equal. But by equating them, I'm solving then the whole thing equal to 0 with my function here. So we're interested to decide where that graph here, where this combined graph would be 0. And we can use this Newton-Raphson method, which relies upon the tangent. Okay, so I'll show you now. So roughly speaking, okay, suppose I've got my f of x here, okay, and I'm given my first x0 value, okay. So my first input is x0 here. What I would do then is, to show you how Newton-Raphson homes in on the root, is I would draw a tangent here, okay, at that particular point in the curve, right? So I'll draw my tangent there, like that. And what Newton-Raphson method does then is, where this tangent cuts the x-axis, which is here, that then will be my x1 value, okay? So I would have to go up to the curve then to find my x1 value, which is there on the curve, and we go through the same process again. So draw my tangent at the curve there, okay? And where that tangent cuts the x-axis is going to be my next input value, so that's going to be my x2. Okay, so you can see now I'm getting closer and closer to the root. So with x2 then, I mean, it's the same process. We're going to draw a tangent now to the curve there, okay? And you can see then it's basically homing in on that root quite quickly, yeah? So that's the process of Newton-Raphson. It's all to do with the tangents, okay? Now, there are certain situations where Newton-Raphson will fail, okay? It won't work. So I'm going to have a look at a couple of examples now. So for instance here, if we are too far away from the root alpha, okay, so suppose the root alpha I'm interested in there, okay, and my x0 is way over here. So with my x0 there, if I draw a tangent, okay, and again where it cuts the tangent cuts the x-axis is going to be my x1, which is here. So you could see it takes me away. If you think about it, it takes me away from my root. I wanted to sort of home in on the root. So if we go back to the previous example, my x0 was here, and we were homing in on the root. So what happens here is that it's sort of diverging away from the root, okay? We started x0 there, and now there's my x1. So if I draw a tangent here, okay, you could see then, okay, we could see then we're not actually getting to that root, okay? We're actually homing in on this root, believe it or not. Okay, so if you keep going like that, we're going to perhaps home in on this root, not the one we require. So if you're too far away, that can cause an issue. One of the main aspects with WJC, okay, is where the gradient is too small. Okay, so that's the sort of question that's likely to come up when the gradient, when the steepness isn't just not there. So suppose I start my x0 there, okay, well, if I was to draw my tangent to the curve here at that point, okay, you could see, well, it's not going to cut the x-axis for a very long time. In fact, it's off my grid here, but it's going to be over here somewhere. Okay, so it's going to hit the curve then up here somewhere. So you can see straight away, there's my x0, my x1 is going to be way over here, and we're going away from the root alpha. Okay, whereas I want to converge on the root alpha, I'm going away from it. Alright, so when the gradient's too small, that could be an issue. And then of course you have an even bigger issue when the gradient is 0. Okay, because when the gradient is 0, suppose I actually had my x0 here, the stationary point, well, it doesn't actually hit the x-axis at all, doesn't it? And it actually fails completely straight away. And that would kind of make sense with the formula, if you think about the formula for Newton-Raphson, because we're dividing by the gradient here, yeah, and that would be 0, so then it would be undefined, and we come to a halt. Okay, so something to think about there with regards Newton-Raphson and whether it succeeds or fails.